So yeah, I'm Jordi. I'm working on the Bogdani project since I think it's 2017. And basically, what we are trying to do is to empower society and empower democracy through implementing the democratic primitives based in Web3 technologies. So yeah, we have been mostly focused on the digital voting part because creating a system that is let's say truly democratic in a in digital systems is quite difficult, and there are a lot of nuances that we can have. And so far on the Web3 space, we just saw solutions that, from our point of view, doesn't fulfill all the democratic guarantees that a secure digital voting system should have. And we have been working on this for the past years. So yeah, the idea today is to kind of a workshop and guide you through what we have been doing, and also showcase some of the products that we built, and also the underlying protocol that powers all these products, so you can get a grasp on what we have at this moment. So yeah, it's we really think that digital voting and any kind of democratic primitives are the tools that will make next generation society thrive. And yeah, that's the idea of the workshop today. So first of all, as I said, I think that digital first participation is how next generation societies will decide together. And the cool thing about digital first participation is that it can be it can be done at any scale, from everywhere, at any time. And that's I think that's also an important point, that we shouldn't be giving up trust. So right now we are in a moment that, thanks to applied cryptography, distributed systems, and so on, the technology is quite ready for starting these kind of experiments, and not that much experiments, but also implement this to real world scenarios. And yeah, Bogdani exists to make that practical, open, verifiable, and free for everyone to use. Just a little bit of background why we started this project. So if we go back to 2017, if we go to Catalonia, the Catalan society in 2017 tried to do a referendum of independence from Spain. And what we saw is that basically the central government of Spain put the military police on the streets. And yeah, if you look in the internet, you will see some nasty images of repression of a nation state against their own citizens for the simple thing of democratically voting on a certain topic. So at that point, people that were working from universities, activists, and so on, started to think about, okay, how we can create a system that is secure for the people to use, so they don't need to fear any kind of coercion, any kind of physical damage for expressing their democratic will. And we started to work on Bogdani, which, by the way, it's written in Esperanto. It's pronounced voice Dani, and it means to give voice. So the idea was to create this kind of transparent, verifiable, and open system that is also censorship resistant and can empower civil society. This is how the project started. But as years passed and so on, we expand this project with the idea to create a universal voting protocol that can be used by anyone to create any kind of participatory process without experimenting what we experimented in Catalonia some years ago. So today in the workshop, the idea is to do this kind of quick intro. We will do some demos running real votes on the solutions that we have been implemented. Then I will encourage you to try to create some proposals using the platform you prefer, and try to vote from your own device. So that way you can actually experiment how the experience it is, and how easy I think it is to vote with what we built. And finally, I will guide you through the SDK that we have for interacting with the infrastructure. So you will see how easy it is to implement this in your products, in your solutions, and so on. Just a few lines of code. So, as I said, we are using Web3 technology, but we always wanted to bring this technology to the real world. And actually, I think we succeed doing so. Nowadays, Blockchain is being used by political parties, unions, professional bodies, and other type of organizations that at least once a year needs to do their votings, and there are other organizations that need to vote in a more recurrent way, for example, once a month or once a quarter. So the idea was to abstract all the Web3 and cryptography complexity from the system, which I think it's quite complex, and to provide users with an easy way to organize voting process and to vote without needing to care on the underlying technology. Because, as I say, doing proper digital voting is something which I would say is really difficult. So yeah, just going back on why digital voting and why now. So first of all, I think societies are going online, especially with the new generation. So communities, DAOs, network states, and cooperatives are forming on the internet. Yet most of them are using platforms like Google Forms, Discord polls, Twitter polls, or WhatsApp polls to decide on important things, and they don't have any kind of guarantee that their voice was actually counted. So that's why I think we are in a sweet spot in history to start implementing this on the field. Also, as I said, trust is the hard part. So a vote only counts if people can read in the organizers, and we don't think that legacy tools can offer that at this level. I think for this we need distributed systems and verifiable computing. And yeah, and as I also said at the beginning of this talk, I think the tech is finally ready. So I don't think it's 100% ready, putting it on nation-state voting or really high-stake voting, like, for example, the Brazilian election or the US election or any kind of European country elections. But we are quite close, and the only thing that is remaining is to have more peer reviewing and more people looking at the technology. So yeah, suspect by cryptography, such as zero knowledge, proof, homomorphic encryption, verifiable computing, and public ledgers, making private, auditable, and internet scale voting is practical today, and it's something that can become a reality really soon. So what's the problem with traditional voting? I mean, I think in Brazil, people is quite proud with their voting system. We can say that it is secure, and it is one of the models to follow, because this electronic, I wouldn't say digital because it's electronic voting, but this electronic voting has been going quite well, and it's something that I think Brazilian people is proud of it. So, but if we go back to traditional voting, so paper voting or in-person voting, we can say it's secure, because it's something that it's been working for the past, I don't know, 2,000 years, starting from Greece. But it's slow, it's expensive, and it's limited to one or different places. But for me, the main point is that it's monopolized by nation states, and it's really expensive. So you need to set up all the physical spaces. You need to spend a lot on this marketing. You need to spend a lot on all the infrastructure that you need for running this stuff. And there's a thing that people normally doesn't comment about, and it's the census. So if you now think about creating a nation-state voting process in your country, the first thing that you will need is this list of voters, because this is monopolized by the nation state itself. So I think that now we have the tools for having these censuses. So basically, it's the list of voters and how we verify those voters. We can have these parts which are monopolized. We can have these parts on the internet, and on the centralized infrastructure, and we can protect. So one of the main points about having this controlled by nation states is that we should care about privacy and the personal information of the people, and this is a really good point. But now we have the primitive for example, using ZK, being able to identify yourself without revealing who you are. Then, if we go to a more digital paradigm, we have Google Forms, Discord, WhatsApp calls, any kind of digital. They're fast, they're free, but they can be trivially tampered, and they're impossible to find. So once your vote, let's say, leave your device, then you have zero tracking, and you have zero ways to verify that if you actually counted. And then on the other side, we have also e-voting, first e-voting solution, but I would say most of them are centralized. Point of, and they're digital, and we know how to scale digital systems, but they are super prone to censorship and manipulation. Because basically, the way that they gain or they offer this security is through obfuscation. And I think we should rely on open source systems for doing so. So basically, you are trusting one vendor with the result of your voting. Okay, so talking again about Bogdani, Bogdani is a free and accessible and an open source voting infrastructure that lets anyone run private, verifiable elections at scale. So that's the whole note about the project. Yeah, I would like you to remember three things about Bogdani. The first one is that it's decentralized by design, so no single party controls the system, the results, or the software. It runs on open ledgers and on verifiable computing environments. And as we say in crypto, in math, we trust. You don't need to trust us. All the code is published. Everything is mathematically provable. And you can just go there, inspect the code, and do whatever test you want. Then we also focus a lot on making a product for the people and a protocol that can be used by any kind of builder. So organizations and their voters can use the app that feels normal. So there's almost no technological knowledge required, and you need basically zero Web3 knowledge required. So you don't need to deal with wallets, you don't need to deal with complex cryptography, you don't need to deal with gas, and so on. And from the point of view of the builders, they can just use a public API or the public SDK that we have published to integrate this secure voting into any application or automate any of their processes. And the third thing I want you to remember is that all we do is free and open source. So you can fork it, you can run it, you can audit it. The only license that we have is AGPL-v3, which basically forces you, if you make some modification in the protocol, to publish it. So other people can, at the same time, can use your modifications, and there's no lock-in. All the information is on a decentralized infrastructure, and you don't need to rely on us. Well, and how the process looks like from when you set up an election to having a verifiable result. Basically, the first three steps are from the organizer point of view. So you can just go to one of the web flavors that we have. You create an organization. You create an organization, which is basically the group that will run the votes. Then you need to create the census, which is the list of voters that is allowed to vote. And then the organizer basically creates a voting process. The question can be one question, multi-question, the options for the voting. So if you want, let's say, single choice, multi-choice, range voting, quadratic voting, any kind of voting system can be implemented on top of the protocol. We have one cool thing called the ballot protocol, which allows you to create these kind of different configurations, and then you set the start and the end time. Then, let's say you publish the election, and now the election is live. Then the only thing you need to do with the voters is to share a link or a QR code, and then this link will bring the user to the voting facing application, which is, as you will see, super simple. So then each voter can cast a private and a verifiable ballot at the end of the voting. Sorry, not at the end of the voting process, but when the user cast the vote, they will receive a cryptographic, let's say, string that will help them to check at the end of the election that the vote was actually counted and was not altered. And then the system, at the end of the voting, will compute automatically the results, and the tally of the voting will be published. And then you will have the results of the voting process. And of course, the last step is to verify that everything was done properly. So anyone, the organizer or any voter, can verify the results independently and can audit the whole process. That's how the voting process looks like from end to end. Okay, now just to talk about a bit of the architecture without going too deep in the technical realm. We have some papers published that I will be super glad to share with you if you're a cryptographer or an enthusiast on CPA stuff and applied cryptography, or even you're an enthusiast on the EVM networks and EVM blockchains. I think you will like it a lot, so happy to share it afterwards. So basically how it works, let's imagine that now we publish the voting process. So the voting process is published on an EVM smart contract, and we have the process live. So from the point of view of the voter, what happens is that the sequences, which is the piece that we have here, will run a multi-party computation to generate an encryption key. Okay, once this encryption key is generated, the voting can start, and the voter will encrypt their vote using this homomorphic encryption. The voter will locally in their smartphone, laptop, or tablet will prove the vote integrity using CK/SNAPS proof. The voter will be authenticated using an Ethereum signature, and the cool thing is that he will be able to override the vote as many times as needed. The thing about overriding the vote is to be able to be coercion resistant. So imagine that someone wants you to vote in a certain way. He kidnaps you and he forces you to vote in a certain way. Then you can, if the election is not finished, you can then cast another vote, and the last vote will be counted. The good thing about this is that this re-encryption will allow you to break also the vote buying problem. So basically, you cannot prove to a third party what you voted. So if you try to sell your vote, the buyer won't have any way to prove that you actually voted the way you said that you voted. So yeah, we are solving here the collusion and the coercion problems. Then if we go to the infrastructure part, we have a centralized network of sequencers. We can call it an L2, but it's not actually an L2 because the sequencers doesn't talk to each other. So they are all orchestrated using a smart contract called the process registry and the sequencer registry. And yeah, on the first step, as I mentioned, the sequencers will do this multi-party computation to generate the encryption key of the voter. And then what the sequencer does is basically verify and re-encrypt the votes. So imagine the voter has actually voted. The vote is sent to one of the sequencers or to a number of them. Then the sequencers will verify that the vote fulfills the nuances of that voting. They will re-encrypt the vote, and then they will recursively aggregate the votes into a single secret proof. As I said, the vote will live on chain, and what the sequencer does basically is with this batch will generate a single knowledge proof that will prove the state transition for this vote, for this specific step of the vote. And then the sequencers will publish the current state root of the voting on any EVM compatible network. The votes are stored in blocks, and then we will have a voter count, an override count that can be later helpful for incentivized sequencer if we want to incentivize them. And then, of course, at the end of the voting, the votes will be computed, we are not going to decrypt them because the votes are homomorphically added. So we are working with encrypted data. So the votes will be never decrypted, and we will be able, thanks to the homomorphic addition properties of the system, to compute the results without decrypting the votes. Then anyone with this can upload the results to Ethereum, and also the results state transition function on the smart contract will also be verified by zero knowledge proof. And then, yeah, we'll have the results, and anyone can trace back all the voting process. So we have 3 actors here. It's or 4. So the organizer creates the vote, then we have the voter, then we have this sequencers that runs this aggregation of the votes and submits proof to Ethereum, and we have all the Ethereum public infrastructure. Anyone can run a sequencer, and anyone can participate in the multi-party computation. So everything it's open. It's not a closed system. Okay. Anyone has any question at that point?
Any questions?
The Web 2 flavor that we built on top of protocol. It's also super useful for this kind of real use cases, that because people doesn't need to hold a wallet, doesn't need to know how Web3 technology works, and it's just a Web3 experience. So anyone that can enter into a website can use it in a super easy and accessible way. You're welcome. Thank you so much for the question. Okay, so yeah, now I will go directly to the live demos. Now that you get a grasp on how the system works. So first of all, the idea is to present the Bogdani app, which is the production app that we have now for the Web2 world, and then I will showcase some mini apps we built on top of the DaVinci protocol. There's a disclaimer here I want to do, that right now Bogdani app is not using per se the DaVinci protocol. The DaVinci protocol is something we want to release by summer, so having a production ready version by summer. Right now, current customers are using another solution that we made in 2018 that is built on top of Termin, and they have like different properties, and we have been iterating the protocol for making something better. But actually, this is an app that is being run on production since 2019, and so far everything was really good, and we didn't have any problem. But just to do this little disclaimer, the idea is that in some months, the existing users that we have on the Bogdani app will be using the DaVinci protocol, which is the latest protocol that we have been developing. But well, nothing will change from the user point of view. Okay, so just let me do a quick overview on how this will work. So we have here the organizer dashboard. Basically, you just need to create an account, and then here you have the dashboard, the voting process that you have, the member base settings, and the support. So this is, let's say, the UI that you will use to launch a vote. we have a free tier, and then we have tires that you need to pay. For example, if you want SMS to have notification, because this, of course, have some infrastructure costs that the organizer need to cover. But there's no crypto knowledge required, just signatures that doesn't even require a wallet. So the wallet is there, but it's embedded into the browser memory, and you are not even realizing that you are using Web3 technology. Then from here, as I will show you, you have different ways of importing your member base. You can add them one by one. You can import CSV files, XLS files, or any kind of these CSV files, or we can even do database integrations. And then when you have the list of voters, you can create groups of voters, which understand them as filters. Okay, so yeah, every vote starts with the census, and you can add the members there. Then this will be the voting creation page. So we have some templates. You can add the questions. You can select single choice, multi choice, you can add as many options as you want. And then you can do some basic configuration, like I want the vote to start immediately. I want the vote to end at this time. I want the results to be shown in real time, or I want the results to be hidden until the end to avoid the wagon effect. We can also apply some voting to some weight to the voters, and then we can just select the census. Then this is the voter experience. Of course, it can run on any kind of mobile device, so it's mobile friendly. Basically, the voter will receive a link, and then he will have the questions. He will need to identify to check that the voter is actually in the census, and he just need to take to select the things that the user wants to vote for, and then he or she will just emit the vote. And yeah, at the end, basically, the voter will see the results, and he will or she will be able to verify that the vote was counted. So now let me close the presentation, and we can do the live demo. Okay, okay, perfect. So, okay, let me put this here maybe. Sorry. Okay, so basically when you enter into the app, you can register yourself, you can sign in with Google, or you can just create an email and a password. Okay, this will create your profile and organization. Okay, so now let's say that I'm already logged into the platform, and basically you will see what I showed you. So you have the dashboard of your recent voting processes, some quick actions you can do. Here we have some tutorial on how to create your first voting. If you want to contact us, you can contact us by WhatsApp. If you need help, also you can contact us by email or by our Discord channels. And basically what you can do here, so you can have in the same profile, you can have multiple organizations. So you can see your organization without even needing to log out and log in. If you like the live team, you can read what a team, yeah, all this kind of basic stuff. And also we support different languages. Okay, so here you have the settings. Okay, okay, no problem. Let me check. Okay, basically here you have the voting process that I already created, and here you have actually your metrics that should be working. Okay, let me check the other one. One moment. Because I just created this organization for the demo, and I think something was wrong. Okay, okay. Let me try to log again. Okay, and let me put this here. Sure. Of the live demonstrations. Okay, so as I said here, I have my organization. I can upload an image. I can select my membership size, the organization type, the country. For example, now I'm in Portugal. Here I can add some team members. So maybe I'm not the that is allowed to create voting, and so we have multi-member organizations. I'm not talking about the voter. I'm talking about the administrators of the voting. And you can here you have your subscription plan that is based on how many voters you have, how many admins you want, if you want to receive SMS, if you want to have a custom branding, priority support, but well, it's not super expensive. Yeah, for an organization up to 1,000 members, I think paying 50 euros a month is not super expensive. And I think compared to how much money it costs to run physical votings, this we can say is super cheap. Okay, so here, as I said, we have the members and we have the group. So first, for example, I can import my members using a CSV file. So I can download a template. I can dump, for example, my database on this CSV file, or we can do custom integration with the databases. And then imagine in this template, we have the user first name, last name, email, phone, member number, national ID, birth date, and the voting power. And we can just import the template here, and everything will be processed. For now, let's just add a member. So let's add myself, Jordi. This is my email. I want to add a phone. This can be my member number, and this will be my birth date. Okay, and I will put one voting power weight. So I'm gonna import this member. So now I have this member here. Okay. Now the next thing I need to do is to create a group. Okay, so I can create a group with all members. So I can group name. I can say this group, and I can add a description. So this is my description. Okay, and as I can see, there's only one member, and I selected one member. And now I can create it. Okay, so now I have the group. So imagine this, as I said, these groups are kind of filters. For example, I want to make people that is older than 20 years old to vote, and I want to exclude people that is not older than 20 years old, or I want to select some IDs, because for this neighborhood, I know that these people living in the neighborhood have this kind of IDs or ID numbers, and then I can add any kind of group. So now that I have my group, I can create the group. Okay, so here I'm creating the group. For example, I can generate some, I can use some templates. So annual meeting and electing, whatever. For example, now I'm going to create an election. So election process title. So this is my election. Okay, I can attach a video, and what you can do, which is something that's been recurring on the organizations that now are working with Bogdani, is that most of the times they want to do a live video. For example, if some people is physically in some space, they want to do a live video where they can read the documentation, ask questions, and so on. So you can add, for example, a YouTube live stream here. So then you can just add this description. This is a description, and then you just add the questions. So we can have a multiple choice or one single choice. In this case, I'm gonna select multiple choice. So, for example, who should be the next president of the community? So here we can add another sub description. Choose your preferred option. And here, for example, I can add some limits. So here I'm saying the voters must select, for example, 2 of the 3 candidates that we have. So we have candidate A, we have candidate C, candidate B, and candidate C. Oops. Okay, I can add more options, I can add more questions. I think I want. Then, for example, in this demo, I want the voting to start immediately, and now I want the vote to finish today. So here it's 3 in the afternoon, so I want the vote to finish at 3. Let's say 3:25. So we can see the results later. For example, here I can select if I want the results to be hidden until the end, or I want live results. In this case, I'm going to select live results. And the voting power I can select. So weighted by voting power, in this case, I added myself 1 of voting power, or I can just say 1 person, 1 vote. Because, you know, we don't like controversies. So in this case, I'm going to say 1 person, 1 vote. And I'm going to select, it's automatically selected in this case, my census group. Okay, I can save this as a draft. Imagine that I want to share this with other people before publishing, so I can just save this as a draft, and then I can show it to other people. Okay, now the last thing is to configure how I want people to identify themselves. So in this case, I added my first name and my last name and my member number. So imagine we are in a community, so we have this information. And now, of course, this is not super strong information, and I want to add a 2-factor authentication mechanism. I can enable a 2-factor authentication, and I can, for example, do an email. So let's say we receive a code by email, or we can have SMS verification, or I can have a call, for example, if you want. In this case, I'm going to select email verification. Okay, here I have a summary. So the required credential will be the name, the surname, the member number, and then the code that I will receive by email. I can confirm this, and now everything is ready. Now the last step is to publish the election, and it will go live. So now I'm going to publish the election. This will be sent on chain, and hopefully the election will be published soon. Okay, so I have my voting process created. Now the only thing I need to do is to get this link and to share this link with my voters. It can be done by SMS, I can send a QR code, I can put a QR code on a big wall, I can send an email, whatever. So in this case, let's go straightforward. Cool thing also is that we have the ability to pause the vote. So we can, if something, for example, goes wrong and we want to pause the vote, we can pause it, we can cancel it, and imagine that we reach the turnout. So at some point, imagine the voter lasts for 1 week, but at the day number 2, everyone voted. So the organizer can end the vote, and then the results will be calculated when the vote is ended. So here we have also some information on the turnout, the total votes, the census size, the voting settings, and of course, as we selected live results. So now, imagine this is the link. So this is the link that the voter will have. I'm copying the link, and now here, this is the web page that the voter will see. So as you can see, it's super easy. You just need to identify, and yeah, so imagine the voter clicks on identify, and then he will ask for the name, the surname, the member number, and the email, where he or she wants to receive the 2-factor authentication mechanism. So in this case, I'm going to put Jordi, my surname, my member number, and my email. Okay, I have read the terms and conditions, and now I'm going to put on receive the code because I enabled the two-factor authentication. So the code was sent. Now I'm just going to go to my email. I received the verification code on my email. So the verification code in that case, it's 029594. Okay, now I'm already identified and I can customize my vote. So as I said, I can select 2 out of 3 options. So I'm gonna vote for candidate A and B, and I selected the options. So now the last thing is to cast vote. So this is a confirmation that who should be the next president of the community, so candidate A or B, and I confirm the vote. Now the vote is being sent to the blockchain. This takes a bit because we are doing some cryptographic calculations here, but yeah. So my vote basically the Web2 flavor that we have. This is the flavor that is being used here in Spain and in other places in Europe by political parties, for clubs like Football Club Barcelona, some cultural organizations, the official College of Nurses in Barcelona. We're also in conversations with the Barcelona City Hall, and this is super convenient to use for anyone that doesn't understand about all the Web3 stuff that we all know about. Okay, so this is the first flavor of the protocol. Let me know if you want to interrupt me and you have any question.
I have one.
Yeah.
So, do you have any plans to develop an interface for cell phone, for example, to make it simpler for persons subject some proposals and for person also to vote? So, my question is about, I see a lot of platforms on the Web3 ecosystem, but these platforms are not so useful for Web2 people that don't know much about Web3. So I was thinking, okay, maybe a cell phone application or kind of this would be good for Web2 people. Do you plan something like this?
Yeah, I mean, the application I just showed is for Web2 people, and it's actually being used by Web2 people, and is an application that actually fulfills all the requirements that we have been gathering since we started the project. And from the organizer's point of view, it's just a Web3 experience. As you saw, I never used any wallet. I didn't interact with any Web3 stuff. and the voter view is just a link that he or she will receive by email or by any other means. And then it's just opening a web page, identify themselves with the credentials, and that's it. And then they can just cast the vote. So this was actually
a mobile application. Did you plan to put a mobile application also?
No. So I mean, this is actually mobile friendly. So you just need to go to the web app. But we already in the past tried to release a mobile first application, and there's a problem with that because people doesn't want to install applications. So what they want to do basically is to go to a web page, and then of course you can build a progressive mobile application. So we plan in the future to just say save this app as a favorite, and then this web app as a favorite, and then you can add it on your mobile phone. Let's say front page, and then you can just click on this, but you will be always redirected to the web application. So this is something that we already tried on the past and didn't work out. So we end up listening to the people that is using the platform, and most of them, or to not say like 99% of them, they just want a mobile application